Look up, what do you see? Is it just an ordinary sky, or is there something more? Maybe a bright blue sky, or perhaps fluffy white shapes drifting effortlessly? These clouds, they seem so simple, so serene. We often take clouds for granted, seeing them as mere decorations in the vast canvas of the sky. They float above us, changing shapes, telling stories, and yet we rarely stop to think about their true nature. But what if I told you those seemingly weightless puffs of white could weigh more than a jumbo jet? Yes, you heard that right, it's true. A single cumulus cloud, the kind that looks like a cotton ball, can weigh over 1,000,000 pounds. Imagine that, 1,000,000 pounds floating effortlessly above your head. How can something so heavy appear so light? The answer lies in the science of clouds. These fluffy giants are made up of tiny water droplets or ice crystals, suspended in the air. Each droplet is minuscule, but together they add up to an astonishing weight. Fasten your seatbelts as we explore the surprising science of clouds. From their formation to their impact on weather and climate, clouds are more than just a pretty sight. They are a floating enigma, a testament to the wonders of nature. So next time you look up, remember there's a lot more to those clouds than meets the eye. Clouds are born from a fascinating dance between water, air, and temperature. This intricate process begins with the sun's energy heating the Earth's surface, causing water from oceans, lakes, and rivers to evaporate into the atmosphere. Imagine warm, moist air rising from the Earth's surface. This air, now filled with water vapor, starts its journey upwards, driven by the heat of the sun. As this air ascends, it encounters cooler temperatures higher in the atmosphere. The higher it goes, the cooler it becomes, losing the heat it gained from the sun. Like a chilled glass of lemonade on a hot day, the cooling air can't hold as much moisture. This is because cooler air has a lower capacity to retain water vapor compared to warm air. The water vapor condenses around tiny particles in the air like dust or pollen, forming minuscule water droplets or ice crystals. These particles act as nuclei, around which the water vapor can condense. These countless droplets or crystals clump together, creating the clouds we see floating in the sky. Over time, these clouds can grow and evolve, taking on various shapes and sizes, driven by the ever-changing dynamics of the atmosphere. This continuous cycle of evaporation, condensation, and cloud formation is a testament to the delicate balance of nature. But how can something so seemingly insubstantial weigh so much? It all comes down to the sheer number of water droplets or ice crystals packed into a cloud. Each droplet is incredibly small, much tinier than a raindrop. But a single cloud can contain trillions upon trillions of these droplets, spread out over a vast area. Their combined weight adds up quickly, even though each individual droplet is minuscule. It's like the difference between a handful of sand and an entire beach. 1,000,000 pounds of what? To put the weight of a cloud into perspective, imagine a Boeing 747 jumbo jet. These massive aircraft, capable of carrying hundreds of passengers, can weigh over 400 tons when fully loaded. That's equivalent to about 800,000 pounds. A large cumulonimbus cloud, the type that brings thunderstorms, can easily weigh more than a jumbo jet. It's a mind-boggling thought that something appearing so light and fluffy could have such immense weight. So, why don't they fall? If clouds are so heavy, why don't they come crashing down? It's a question that might seem puzzling at first glance. After all, clouds can weigh thousands of tons, yet they float effortlessly above us. The answer lies in the size and distribution of the water droplets and the updrafts of air within the cloud. These droplets are incredibly tiny, often just a few micrometers in diameter. Because of their small size, they don't fall quickly. The tiny droplets fall very slowly due to air resistance, much like a feather gently floating down. This resistance is enough to counteract the force of gravity, preventing the droplets from plummeting to the ground. Simultaneously, rising warm air currents within the cloud, called updrafts, help to keep the droplets aloft. These updrafts are created by the sun heating the Earth's surface, causing warm air to rise and carry the droplets upward. It's like a delicate balancing act between gravity pulling the droplets down and updrafts pushing them upward. This balance ensures that clouds remain suspended in the sky, creating the beautiful and ever-changing formations we see. So next time you look up at the sky and see those fluffy clouds, remember the intricate dance of physics that keeps them afloat. It's a fascinating interplay of forces that makes our sky so dynamic and mesmerizing. A universe in every cloud. Clouds, despite their seemingly simple appearance, are complex wonders of nature. They are a testament to the power of natural forces and the delicate balance that exists in our atmosphere. Next time you gaze up at the sky, remember that those fluffy white shapes are not just whimsical decorations, but massive, dynamic systems holding unimaginable amounts of water. They are a reminder that even in the most commonplace sights, there are hidden depths waiting to be explored and understood. Thank you for watching. If you enjoyed this video, please like, share, and subscribe for more fascinating insights into the wonders of our world.